Greetings, class. Good to be with you again. Trying the webcam this time, so we'll see how it works. Whitlock Schluter Chapter 3, describing data, measurements of center and spread. Now, we're talking about the raw materials of statistics again, which is data / random variables. There are three key properties: shape, center, and spread. I'd like to get at these using a diagram here. If we want to build something, then we get raw materials. We might use wood because it's light and rigid, metal because it's strong and malleable, plastic, it's cheap, it's light, and so on. Now, we select those materials on the basis of the thing we want to build. For example, for the house, we like light, cheap, and rigid, so we use wood. But for the computer, we need malleability, so it requires metal, and so on. Now, the data / random variables, we're back in chapter 1. Those correspond to wood, metal, plastic, different variables, different properties. What are those properties? Well, they turn out to be shape, center, and spread. I've called those the three key features of a data set. Now, the rest of this book and class, we're going to be building not houses, computers, and satellites, but the statistical tools, confidence intervals, hypothesis tests. Certain graphs can be used even for inference, correlation, regression, and these kinds of things. Okay. Now, let's start off with shape. Okay, so for shape, we've done this last time. We have the 5 common shapes. Now, what they give us is how the data is distributed. If it's rectangular, everybody's got the same chance. If it's mound, most things are in the middle, but there are those rarer events farther out symmetrically. Skew, you've got extremes on one side only. Bimodal, you've got some division within the population. Let's go to center. How you doing? On average, I feel fine. Okay. Measures of center. The word average is a word that describes just one number that measures the center of a distribution. We're going to look at 3 special averages. Okay, the mean, or arithmetic mean, is the one that you're most familiar with probably. It's just when you add the numbers and divide by the sum. Now, we want to distinguish between population parameters and sample statistics. So let me review. When we collect data, we have a population. There's some random variable x that we're measuring, and that population has, let's say, some mean, mu, average. We collect the sample, and the sample has x bar, a sample mean. What's the difference between those? Well, if you'll turn back in your notes, it's chapter 20, I've got a table that has the mean for the population parameter. It's mu. Okay, mu is sounds like flu. I give a little indication for it here. So basically, you draw it like a U, but there's a long line on it. So that's why I do something like this. I just do the leg first and then that. So mu. That's mu. Other properties of data sets are summarized here. So let's go back to where we were at. Okay. Now, how do we denote this? The population mean, we use the Greek S for sum of all n observations on x. So that's I running from 1 to n divided by n. Okay, just for the record, the sum of I equals 1 through 5 of xi is x1 plus x2 plus x3 plus x4 plus x5, whatever those happen to be. Okay. Now, I've got little n here. Let me use big N, where big N is the total, and then I running from one end of little n there. So let's put a big N up here, and we're going to have n equals sample size, whereas big N is population size. All population size. Okay, that's all the observations in the entire set. That's called a census. Now, the median is the middle number in an ordered set. Middle number in an ordered set. I'm going to do examples momentarily. Mode is most frequently occurring number or numbers, and I denote that by the peak of the histogram. Okay, we'll see that. Now, let's take a look at these three, and we're going to do it by going back to last chapter's distributions. So, sorry for that trip that I just gave you there. We're going to come down here. And for this graph, let's flip out to a different color. We'll use, let's just do purple here. Okay, the center for a die is about right here, 3.5. We can see, looks even better on this graph. 3.5 is the middle. That is the average that you would get if you rolled a lot of dice and took their arithmetic mean. Okay. Center for this big guy, sure enough, that's it right there. Boom. Got a nice looking center. For the coin toss, we're going to get between 2 and 3, so that would be a 2.5 heads expected. IQ, we're going to get 100. Looks great. Okay. Now for this guy, what do we do? The mean is going to turn out to be somewhere in here. I calculated it one time. Now, does that visibly give us a measure of the center of this distribution? No, it does not. Okay. That's why we need to use a median. Median, you put all the numbers in order and take the middle one, and that's going to give us a much better measurement here. Okay. If you're in this market, you wouldn't be interested in hearing, oh, the mean housing price is $400,000. It would be much more informative to say the median housing price is $301,000. That's going to be a much more informative number for you, the young home buyer. Okay, now let's just back up here briefly and note that the mean equals median for symmetric distributions. So the median is going to be same spot as the mean for all three of these guys. So that's covered. Okay, great. Now, median works great for a skew distribution. Median's going to work great here as well. Not sure, probably pop in somewhere like that. What the median does is it gives me the breakpoint where there's 50% of the values on one side and 50% are on the other side. Those values are the area added up underneath of that curve. Okay. Clearly the mean's going to be big because we have an extreme value there. So okay, median, something like that, a lot better. Okay, so we come into this one, boom, 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 median. It's already marked. And then the mean is marked for us here. Well, look at those values. Are those doing well for the law school graduates? Oh, no, they're not. Okay, what's the issue? The issue is it's bimodal. I'm actually interested in the value that gives the peak here and the value that gives the peak here, far on either side of the median. Hence, we're interested in another measure of center, namely the mode. Okay, so that's why we need all three kinds of average, mean, median, and mode. Now, as I pass out of this, let's note that if we have a symmetric distribution, rectangular and mound, then the mean was equal to the median. But if you went skewed to the right, holding this thing tilted like this, then your mean is going to be greater than the median. On the other hand, if you're skewed off to the left, your extreme values are on the left, then your mean is going to be below. So we'll have the mean here. Here's mean. And we'll put the median here. Median. Okay. And let's do that again. Mean. Here's the mean. Here's the median. Okay, great.